Broadcasting from Studio 202 at the Springett Technology Center in Navasota, Texas, it's NOV Live. Now, let's start the show.
Hello and welcome to NOV Live. We are live in Studio 202 at Navasota, Texas right now. I'm your host, Shelby Dumaine, and we have a really incredible show planned for you today. We're actually going to take you inside of a facility as well as talking to the experts themselves. Before we get to them, we just want to share a little bit about how you can get involved in the show. As I said, we are live in the studio right here, right now, having this conversation, and we want you to be a part of it. So we're going to bring it over to Christian Hay, and he's going to tell you how you can be part of the show.
Thank you, Shelby. I appreciate that. If you guys have any questions for our guys here today, be sure to drop them down in the comments. I'll try to get to as many of them as I can before the end of the show. And if I don't get to them, feel free to reach out to us and send us an email, and we'll try to get back to you by then as well. So that's all I got, Shelby.
Excellent. Thank you very much. And I did want to shout out the email address we have. If you need to get in contact with us, you can email us at socialmedia@nov.com. But with that, I want to get right into it. We have enough time to go over all of the excellent information we have for you today. With us in the studio, we have Zachary, Todd, and Tony Trower. Just to kick us off, gentlemen, can you tell us each a little bit about what you do here at NOV? We'll start with you, Zach.
Yeah, my name is Zachary Todd. I'm the regional manager for North America here for our Directional Drilling Technologies business unit. We primarily focus on manufacturing and developing products that are used for measurement while drilling and logging while drilling, also rotary steerable tools, and some vertical seeking measurement tools as well. So glad to be back, and thanks for having us.
Yeah, absolutely. Tony?
I'm the service center manager in Oklahoma City. I oversee the shop and all operations in the field that have to do with MWD and drift. I also oversee the global side that comes out of our facility.
Excellent. And just to kind of give the audience an overview of what we're talking about today, a bit of an introduction. I know you can do a better job introducing it than I can. So, Zach, can you tell us what we're going to be talking about today?
Absolutely. So today we're here to talk about a new MWD technology that we've been working on for some time now that we're going to be bringing to the market in a big way. This technology is something that's going to be replacing some older technology that was actually developed way back in the 90s. And NOV has taken an opportunity to evaluate that, and we think that there are a lot of restrictions with that, and we think that this new technology that we're bringing today for the MWD world is really going to help us get to the next level. One way that I kind of think about this is I used to work in the drill bits business back when I was in college. And one of the things that I would do is I'd get up in the morning early and I'd load my pickup truck with lots of different drill bits, and I'd go hit 10 or 12 rigs throughout the day. And I can remember distinctly one morning going to visit one rig, and I went to talk to the company man, and I asked him if he could come outside to my pickup so I could show him something. And he comes outside in the heat of the day, and I've got this big black wooden box sitting on the back of my tailgate already kind of set up, and it looks different from any of the other boxes that are back there. And I unlatch it and I open it up, and I remember him looking at it, and he said, "How much does this thing cost?" And I told him, and it was a little bit more expensive at the time because it was new.
Right.
And he just shook his head and he looked at me and he said, "Son, that ain't never going to take off." And he was looking at a PDC drill bit.
Oh.
And in a sea of roller cone bits on his location.
Yeah.
And, it just looked different. It had fixed cutters. It was a totally different type of design and concept. But he had been around for a long time. And as he looked at that, it looked new and different. But what we had realized is that the roller cone technology of the time had really reached its technical limit. There wasn't a lot more that we could do to develop that tool and get to that next level of performance. And I don't know if you're aware of how many roller cones we sell today, but it's not very many.
Right.
PDCs have taken over, and the rest is kind of history. In many ways, that represents what we're talking about in the MWD space today. Historically, we've been using what we call a retrievable MWD mud pulser that comes with lower end assemblies. And that technology was actually developed and patented back in 1994. I think we actually have a picture of the patent here to reference.
Oh, yeah.
And, in much of the same way, we feel like it's, for many reasons, reached its technical limits, and we've got to do something different in order to continue to push the envelope and keep up with today's drilling demands. So we're going to be introducing the Hellfire top mount pulser. And it's much the same way with the PDC. It's got some differences in the way it looks and how it's used, but we think there's going to be a lot of benefits. And just to kind of frame that discussion, I think we've got a picture here that shows a Hellfire top mount pulser on the top left-hand side of your screen and how it's positioned at the top of the bottom hole assembly. So you've got a drill bit and a mud motor and an MWD. This is your drilling BHA as you're going. And these MWD tools are responsible for measuring the downhole environment, the shock and vibe and lithology and other things. And then they take that information and they communicate it to the surface via mud pulse telemetry or mud pulses. So the top mount pulsar is a different way of achieving that. And the bottom mount pulsar that you saw, the retrievable pulsar, sits on the bottom of the assembly. And I think you had a chance to see some of this recently.
Yep, I was just going to say, so yeah, I mentioned at the beginning that we were going to take the folks joining us today live into a facility. And that is because earlier this week, y'all welcomed me into the facility in Oklahoma City and showed me around. And actually, we wanted to go over to that. And what we're going to start off with, what folks are going to see when we go into the facility is, I had asked you, Tony, a little bit about the kind of the differences in the old versus the new.
Right.
So we're going to go ahead and show that video for the folks at home. And I want to ask you real quick. So at the top here, have I heard right that it hasn't really changed much since about the 90s? Is that
No,
right?
it's what you'd like to call your grandpa's trusty one. It is what it is. It has been doing its job for over the last 20 to 30 years. It's robust as far as compact, but the longevity of runs is just not there. You have to nurture them and clean them and do multiple things after every run. The plus of the top mount is you do not have to service it in the field. It runs multiple runs. You can get longer hours out of it without servicing, and we feel that this would be a great benefit to people.
Tony, can you help us understand why this lower end is causing so many incidents in the field?
Oh, yes. So as you can see, the lower end is this section right here, the tool. And it hasn't changed the basic design has not changed in about 30 years. It is what it is. You have multiple parts on here that have to be replaced after every run. They have to be serviced after every run in the field. The only changes you can really make is consumable parts that you can re-engineer somewhat or design to help with flow, but the basic structure and buildup of it is always going to be the same. You have ceramic pieces that are susceptible to cracking and breaking out. You have poly packs that will break while drilling, which once those things go, you have to trip, and nobody likes to trip for little things like that. So the wear and tear that these go through and are serviced by field hands in the field instead of technicians in a shop after every run is a liability in some ways. And the technology is limited right there. And then you come down here to the top end section. It's a more robust area, and the parts are bigger, can handle different drilling environments that today's market has. The consumable parts have been engineered out as much as possible, so we have more of a steady stream going through the tool of mud flow to help with eliminate failure points and help with consumable parts that you just have to replace repeatedly over and over again. And then we have different designs in the top mount. This is a 6.5, so it's, you'll drill the 8.5, 8 3/4 sections with it, and it's set up for that environment in a hang-off sub. If you go to a bigger tool environment where you're running 8-inch tools, we have an 8-inch package right here, and then you have a 4 3/4 package for slim hole sections. The biggest thing that I can say is these tools are locked in at the top of the BHA, and the mud flow that is impacting the tool at the top lessens the chance of failure due to vibration or washouts.
It's more customizable than the former.
Correct. You can do multiple things with it in the BHA. You can set it up for your drilling parameters if you have a high LCM count, if you're You know, you're gonna have areas where you're gonna have to lower your flow because you have losses. This tool can handle that and not skip a beat. If you choke down an orifice poppet configuration, then maybe when you go to that lower flow rate, maybe it can't handle that because of the way that you set it up for being out, stretched out in a lateral. But this tool over long areas, it will not change.
Right.
So.
Tony, the team here has been able to create a really incredible piece of technology. Can you tell me a little bit about the challenges that y'all overcame to get where we are today?
Yeah, of course. I'm glad you asked that question. So we took the older style top mount pulser and re-engineered it where we use the drilling dynamics of the mud flow to assist with the pulses and the pulsing section that lengthens your battery life down hole, which also will save on your consumable parts on your batteries and things like that. But by doing that, we had to re-engineer this section right here mainly because these parts are actuating inside of the cylinder, which helps create the mud pulse and reduces the battery consumption down hole.
Yeah, I think that's really what's unique about this new technology is what you're saying there.
Correct. So this area right here was engineered and designed, and during that time we had multiple deployments, and we had to learn over that time that this is the main part where we needed to focus on and create good mud pulses over long drilling dynamics, long drilling areas and difficult drilling dynamics.
Right.
So.
All right, we're in the shop now, and I wanted to first say, hello, Mike. Can you introduce yourself to the folks at home?
Yeah, I'm Mike Vaquera. I am the primary tech here at NOV for the top mount pulser.
And I think I walked in on you, taking apart the TMP here,
Yeah,
right? Is that right?
yeah,
Can you talk us
correct.
through a little bit of what you're doing?
Well, we got several different styles. This one here is a pressure while drilling TMP. Takes a little bit of different electronics. We have to service these as they come back in from the shop. That's kind of what I do. I have a bunch of different parts here, as you can see.
So Mike, can you tell me a little bit about what you see when these tools come back to you from the field?
Oh yeah, absolutely. So we have, this is our poppet and orifice configuration. It sits up here in the top end. This one actually belongs to the tool that I've been working on. These are brand new, so this is really what takes the brunt of most of the drilling fluids that come down hole. And they actuate in and out. So this is what actually restricts the flow and causes the mud pulse to go back up hole. This one, like I said, was brand new, built for this PWD here. This one is our 6.5. We've had about 250 hours or so on this one.
Wow.
And it's exactly the same thing, just a little bit bigger. And the condition of it, so yeah, it's a little dirty, but this is going to run another 250 hours.
That's incredible. Yeah, it looks clean for 250 hours.
Right.
Absolutely.
Yeah, these are very robust. It's a lot of heft there.
So now we're here with Landon. Landon, first off, can you introduce yourself?
Yeah, Landon Williams, the tech for NOV, and as you can see here is a pull string TMP. It's getting ready to go out. This is top mount pulse. The mud flow comes from this direction on down. This landing sleeve here helps secure the tool, and then we have each component plugged in as we're testing.
Excellent. And can you walk us through the components that you have laid out here today?
Sure. So obviously the TMP, then we have a battery, and then we have the directional module here, and then we have another battery right here, and then the gamma right here. It goes, and then your bit will be here. And as you can see, we have the invert flow on, and we're testing.
All right, so we're back here with Mike. And Mike, I see we're all plugged in here. Can you tell me a little bit about what we're looking at?
Yeah, absolutely. So once we have a string, it's getting ready to deploy, we want to make sure that we test it, make sure that everything is reading correctly. That's what we have here on the screen. We have the ability that we can talk to each one of the components separately, or we can string the whole thing up together and do that, which is astronomical in the field because we can do that on the job site, read how every tool is picking up vibrations and shock and all that. We can make a decision on the fly right then whether or not we want to rerun that tool or not.
Right, I can see how crucial that can be.
Absolutely, and then we can also bring that back into the shop after the run is done. We can take all that data, compile it, compare it to what happened while it was in the shop doing the pre-deployment testing.
Yeah. All right, well, first off, gentlemen, I just want to say thank you so much for having me at the facility earlier this week. It was so great to actually see the technology in person, in front of me, and get that explanation. Was just so valuable.
Yeah, no, we appreciate you taking the time to come. I mean, it's great to be able to walk through that and get some other perspectives, and I think it was great. So thank you for coming.
Yeah, absolutely. So back to kind of interviewing y'all, getting the expert input here while we have y'all. Zach, like I said, we could see the facility. The team has been hard at working on this. So can you talk a little bit about how the Hellfire TMP is making an impact for our customers?
Yes. So as you saw there, kind of visually, you could see the tools.
Right.
As Tony was walking through the setup and you were looking at the different sizes, for instance, the first thing I would say right off the bat is that when we're not having to deal with the performance objectives of 1994, which is really retrievability and being able to pull out those probe strings. If your BHA gets stuck in the ground, we're not constrained by that. We're able to maximize every square inch of space in pursuit of today's objectives, which is really longevity, reliability, and very tough drilling conditions, high vibration environments, extended laterals, multiple miles in some cases, needing to get that mud pulse telemetry back to surface in a stable, efficient way so that it can really be decoded consistently. And there's been a lot of work done on surface systems and things like that to help with it. But you really need to get the mechanical unit itself that's generating the pulse dialed in to make sure that all that other innovation is really able to be capitalized on. So as you saw there behind Tony, there was an 8-inch TMP pulsar, and it's really large and robust looking as opposed to that little bitty probe that you saw.
Right.
And that's an example of how we can really take advantage of this new space. So you get much bigger parts and pieces that enable more stable environments. As you can see on this picture here, it actually locks into the collar at the top of the drill string, which promotes a number of benefits. When you lock that in, you're going to get more vibration resistance. It enables you to get more stable measurements themselves, which we'll talk about in a minute. But it also puts the tool at the top of the string. And the reason why that's really beneficial is because it pushes all the rest of those measurements that directional drillers and drilling engineers and lots of people are reading in real time to help steer. So the closer we can get those measurements to the bit, certainly it's going to be better. So there's a number of benefits from that perspective that we've been able to take out to the field and verify in multiple runs and see that.
Absolutely. Yeah, that was something I got take away from seeing it, I think, largely was the customization. There we go. Ooh, it's the morning. The customization of these parts with the different sizes just seemed way more detailed and more flexible for different operations and different sizes. So I thought that was really interesting.
Absolutely. Yeah, that's right. I mean, I think one of the big things that Tony will probably talk about here in just a minute is we really had to design this thing where it could work across much wider flow ranges as opposed to some of these retrievable assemblies that can be a little bit finicky as you have different environments changing downhole.
Right. And so speaking of kind of the older retrievables, I think we talked about in Oklahoma City, I want to say it was in that video as well, that 30% of issues with MWD comes from these older retrievables. If I were a customer, what should I be aware of? What should I be looking out for when I'm doing these operations?
Yeah, so when you're drilling along and your pulse amplitude is falling off throughout the runs, especially like Zach touched on with the extended reach laterals, and during that time, you're drilling ahead and you have high vibration and shock, which, will interfere with your signal coming up hole, which your data set isn't as dense. And by doing, drilling ahead in those applications, you could have mechanical issues, as I showed some of the mechanical parts that are in there. The breakdowns in that, your pulse height will slowly dwindle down throughout the run, or all of a sudden you lose complete pulses as a whole. But you also have to think about the wear and tear that the lower ends and the retrievables go through
Right.
throughout that time, and how they're being maintained, the consumable parts that can break while downhole, that get replaced constantly, typically by field hands that are servicing these parts out there. And the field hands do a great job of working on those things, but if you're having to service those repeatedly in the field and you have wash points and breakdowns, your cost goes up because you're just constantly changing parts out repeatedly. And if you go in an extended reach lateral and it's a longer run, maybe your poppet orifice configuration isn't set up to go that entire run. So one of the downfalls is that you have to set up for the complete run, and the damage that the tool will receive by having to operate at such a long distance over longer periods of time due to the technology advancements.
Absolutely.
So
Yeah.
One thing I mentioned there, Tony, is, like we've talked about a while, and I know that there's been multiple different types of offerings on the market that try to help minimize some of that shock and vibration, additional tools and other things that are really trying to mitigate that. And that's just another reason why we think going to a top mount and sort of eliminating all of those challenges altogether provides a lot of benefits, plus the fact that you're not having to tear into the tool on location.
for sure, you don't have field hands that are working on it that either could be worn out from long hours, or maybe they're new and maybe they just, it eliminates some of those things by running a top mount.
Right. Yeah, Mike was showing us, again, it's in that video, but when we were in the shop and he was showing me some parts from the TMP that had come back after it had already gone through, I think, something like 250 hours. And I'm telling you, it looked brand new. I mean, apart from maybe a little bit of cleaning, I was amazed by how little wear and tear there was on the TMP, what we're talking about, the new tech.
Yeah, that specific application that you're talking about was a pretty challenging deployment. I mean, I think it was, it was one of our mid-sized tools, but it had been in the ground with no changes whatsoever to that assembly for over 250 hours, which is pretty significant for an MWD string. And it was going through pretty harsh mud conditions, high LCM, high flow rates, extended reach application. And when we got it back, we wanted to rip into it and really take a look at it, and that's what we found.
Yeah, it's pretty amazing.
Yeah.
And on that, Tony, can you tell us a little bit about maybe some examples of field deployments where the TMP improved performance?
Yeah, so over time, we've had multiple deployments, and we've been lucky enough to have retrievable deployments followed by TMPs, and vice versa, TMPs followed by retrievable in the same wellbore. And during that time, we were able to do a comparison, and we have an example, I believe, up here showing that. On the top is the TMP, and on the bottom is the retrievable. And this chart, I know it's kind of small, so people might not be able to read it very well, but it's the shock and vibration that the tool was seeing downhole. And as you can see on the bottom, some of the shock and vibe is reaching 90 Gs.
Right.
So you can imagine what that's doing to your tool string downhole and your pulser. So with the bottom mount retrievable, you can see the vibration was quite a bit higher, and that will affect your live data that you're getting up hole, your real-time data that can affect the drilling. And then the top graph shows that reduction by 40 to 50% in vibration. That really shows, it mitigated that vibration just by mounting that top mount in the top of the drill string and locking it in. That gives you more accurate real-time data for steering, formations, and stuff like that. So the operators can make a good decision on, do I need to make a change here? Do we need to do something now? Versus getting data that is fragmented and causing you to second guess yourself if we should make a change or not. And, we've been lucky enough to have that ability to compare and work through as we do that to make the changes for the real-time feedback to make inclination and azimuth, especially to be more accurate for real time, so we can make the right decisions. So.
Yeah, you could just imagine in a downhole drilling environment where we're going this fast with this vibration environment that he's talking about, things are really, there's a lot of dynamics happening. And when you're trying to take continuous measurements while you're drilling, that can be a very difficult environment. So if we can quiet that down, which we're able to show here, I think we were able to actually calculate a 38% plus improvement, I believe, in the accuracy of those continuous measurements as you're drilling, in addition to the fact that they're actually closer to the bit.
Right.
And I think a plus to that, the LCM side of it can affect it. And if you are pumping high LCM because of losses, the TMP is taking the blunt of that LCM coming down and can disperse it and break it up and will not pack off as bad as a retrievable could, as you saw how more robust all the pieces are and the components versus a retrievable setup.
Gotcha. And can you remind me what LCM stands for? Anytime I hear an acronym that I can't remember off the top of my head, I try to ask.
So, lost circulation mud.
Okay, yeah, I've heard that one. Okay.
It's like they use it to pump down hole if they're losing returns or clean the hole up or whatever they need to do to bring cuttings up, essentially is what it's there for. So it'll be cedar fiber, or you could have beads, you could have all types of stuff. I'm not a mud guy. I just know that it can affect the MWD big time. So
I appreciate that. Anytime, I'm sure there's got to be viewers out there that are like me, and there's so many acronyms in our industry that sometimes if I hear one, I'm like, I gotta ask.
Well, I mean, it's a good,
So I
it's a good
appreciate
point. If you're drilling, you could just imagine, you got your geological formation down there, and depending on what that's like, the mud column that you're pumping down hole can actually escape. That's one of the big issues, and you could have losses. So in order to try to plug those holes and keep the mud column the way it's supposed to be, you pump this lost circulation material down hole. And as you saw on the videos, you had that poppet orifice configuration that was going back and forth. In the older retrievable style assemblies where you were restricted on space, you had to restrict the actual space that stuff could flow through. So if you look at the poppet orifice configuration on what Michael Vaquero was showing on the film, it's much larger with bigger flow areas that creates a much better environment for that.
Wow. I love how it's all kind of connecting, and even now that a couple of days later, I'm still piecing all of this stuff together. It's so fascinating. So
hey, well, you'll be an expert before long.
I hope so. Well, Zach, I want to ask you as well, are there any other considerations people should know about the Hellfire TMP when we're looking at it?
Yes, we've got one big one that we think is going to be very attractive in the field. One of the things that we've been working on is using the top mount technology that we've got in conjunction with third-party rotary steerable systems. So it's pretty common, especially in U.S. operations, and I'm sure in other places in the world too, where a directional service provider can go out and source a third-party rotary steerable system, and there are some very popular ones out there. What we've been able to do is work with those systems and develop a piece of technology that enables us to communicate with those third-party systems. And it takes the information from the rotary steerable system as you're drilling in the well, communicates that information to the MWD string, and then pumps it up hole. And what that gives you is the ability to get real-time feedback from third-party equipment that traditionally wasn't designed to speak across platforms. And that's become more and more common, and one of the challenges is making sure that you've got the compatibility and the firmware and everything written so that it can do that. And B, it's actually the mechanics of how you're trying to get them to communicate with each other. So you could imagine if you've got a rotary steerable, if you've got a bit and then a rotary steerable system and then an MWD, you're trying to get two components to talk to each other. When you put a retrievable pulsar at the bottom of your MWD string, it really disjoints a lot of the communications that we're trying to achieve there. So by removing that piece out of the string, putting a top mount pulsar at the top of the string, and then pushing all of those other components further down, you create a much better communication profile. And so we've been working hard to make sure that that's something that's available off the shelf with some of today's most popular rotary steerable systems. And in addition to getting all of the real-time communication and all of those things that we've talked about, you get all the benefits of running a top mount pulser in environments that rotary steerable systems are in. Rotary steerable systems are typically in environments that are long, hard drilling. So you get all the benefits of running a TMP along with that.
Wow.
So I think that's one of the major differences here. And if this is something that you're running in your applications, we definitely encourage you to talk with your vendors or give us a call directly, and we're happy to walk them through how we can make that happen.
Definitely. And so now we've shown the folks at home, our audience, we've brought them into the facility. They've gotten to hear from y'all a little bit. Before we, get to them to answer their questions, I just want to ask, do you have any closing thoughts that you want to leave them with before we get to that Q&A?
Yes, I think the main takeaway here is, obviously drilling applications have changed significantly in the last 30 years. And we're going to continue to push the envelope as an industry. It's something that we're very good at, something that we support heavily here at NOV with all the technologies that we're working to develop. But I think in this case, we've identified something that really is ready for a significant change. I think that's clear as you kind of walk through and look at, the design of those components. It's pretty evident. So I would just say that, this top mount pulser provides a lot of solutions. In terms of its vibration reduction, eliminating common failures, pushing measurements closer, working with rotary steerable systems. It's really designed for the 21st century drilling application.
Yep.
And, we need to get the system out there. And, I think the main thing I would recommend is get in touch with your vendors, make them aware of the technology, and let's have a conversation about it. I think this is going to be a game changer, and we're excited to get it to the market.
Yeah, absolutely. I mean, that was my takeaway too, is that we did a social a couple posts the last week or so where we talked about some other 90s tech that we don't use anymore, pagers, floppy disks, VCRs, I think we did cassettes. All that stuff is, we don't use that tech from the 90s, so why are we still using these retrievables from the 90s when we have the better tech available now? So thank you all for showing me around. But like I said, we do want to give the audience a chance to have their questions heard. So we are now going to go over to Christian Hay, and he's going to give us some questions.
Appreciate it, Shelby. We just got a couple here. The first one is, how long can the Hellfire TMP drill using 2 batteries? And is it only powered by a battery, or is there a turbine as well?
So we've had multiple runs where the tool's performed up to 250 hours, 150, 200 hours downhole, and the batteries come out and the consumption is very low, and you can continue on. I would say that the battery consumption is less due to the assist through the pulse, and it uses less battery the way the tool is designed. I don't know. It's without being too detailed, I'd say it's not a battery hog. Your battery consumption is similar to a retrievable.
I think a good way to frame that, the way I think about it, is just that it is the case historically that there have been some top mounts on the market that have consumed a lot of battery because of the way that they're designed and the way that they actuate and make those pulses. One thing that our engineering team has really done a great job on is creating a system that Tony had mentioned when we were in the shop, where it uses the energy and the mud itself to assist in creating those pulses. And by using the mud column and the pressures there, you reduce the burden on the battery. So as Tony's saying, I think you're going to see that it's going to be very similar to a retrievable assembly.
Excellent.
Okay. What sizes and configurations do the pulsers come in?
So we have multiple sizes, all the way from 8-inch that you'd use in your top hole sections, in your intermediates, and then we have 6.5s that can be used with 6 3/4 tools, and then we have our smaller 4 3/4 TMPs. We have various sizes, various connections for hang-off subs that can use for multiple applications, and we can change up the poppet orifice configuration depending on those and where they're at in the well to maximize it.
I guess one thing to add there is you also have the ability to add pressure while drilling like Mike Vaquera had mentioned on the camera, and that's integrated right into the tool, doesn't require any other components, and that's going to give you borehole pressure, annular pressure, and differential straight from the tool. So there's some other benefits there as well, and that's a low-cost option for you.
And very minimal change to the
Right.
tool.
Yep.
And it works very well.
Yep.
Yeah, and I think if folks, I know you can't really rewind in a live, but these videos afterwards you can rewind. They're on NOV.com/live as well as our YouTube. But we actually show the different sizes. You kind of help walk me through those. So if folks are interested, they can go back later and kind of take a closer look at those. I think we have one more.
Yeah, one more, Shelby. Are these able to be deployed in remote operations?
Yeah, so that's actually something that we've been working toward. Because of the nature of having a top-mounted system, this is actually something where we can deploy it to the field in a collar with the probe strings and everything already assembled. And we've got some other technology that we can incorporate that essentially allows you to pick up a collar and have it turn on and activate. And then when you drop it below 45 degrees, it turns off in vertical drilling mode. Or if it's in horizontal drilling mode, it won't shut off. So this is something that we think is going to be able to support the trend towards remote operations, the ability to deploy equipment in a way that can be picked up in the field with minimal personnel and run down hole and then monitored remotely with minimal human interference. So yeah, absolutely, this is going to help pave the way for that.
Excellent. Well, thank you so much for submitting those questions. And if you have more questions or you just want to check out more about the Hellfire TMP, we do have a link. So we're going to show it on screen. It's www.nov.com/HellfireTMP. So that's the webpage. There's our contact us option there. So that's how folks can get in touch. But I just want to say thank you so much. I really appreciate it. I've had such a great week. Getting to go to Oklahoma City, then come back to here in Navasota, Texas, and talk to y'all. And I appreciate, hopefully, we'll have even more conversations in the future.
Well, thank you for coming up and having us on, and it's been great.
Absolutely.
Yep. Thank you very much, Shelby. We appreciate it. And thanks for having us here. And if you guys have questions about the Hellfire TMP, please let us know.
Will do. And with that, thank you so much for tuning in today. This has been NOV Live. I'm your host, Shelby Dumaine. Our guests today were Zachary, Todd, and Tony Trower. We also had Christian Hay on social, and on production, we had our great team, Paul Dufio and Wei Han Lin. So from all of us here, thank you, and we'll see you next time.